In a world where every device relies on microchips, the machines that print these chips are the unsung heroes of modern technology. One such machine is ASML's extreme ultraviolet, EUV, lithography system. Imagine standing inside a clean room where the air is filtered to remove even the tiniest particles. This environment is crucial for ensuring that chips are manufactured without defects. The heart of the process is extreme ultraviolet light, which has a wavelength so short that it can etch patterns onto silicon wafers at an atomic level. This precision is what makes EUV machines indispensable. Consider the iPhone. The A-series chip inside it is manufactured using EUV technology, enabling features like advanced AI and high-resolution displays that would be impossible with older methods. The EUV process involves a complex series of steps, including the generation of light by firing lasers at tin droplets. This creates plasma that emits the necessary UV light. The control of EUV technology is not just about manufacturing efficiency, it's also a matter of geopolitical power. Countries and companies compete to secure access to these machines. The supply chain for these machines is incredibly complex, involving components from around the world. Any disruption can have far-reaching consequences. The economic impact of these machines is enormous. They enable the production of chips that power everything from smartphones to autonomous vehicles. ASML's EUV technology has advanced rapidly, with new generations of machines pushing the boundaries of what is possible in chip manufacturing. In summary, ASML's EUV machines are at the heart of modern chip manufacturing. Their precision and complexity make them indispensable for producing the chips that power our world. Understanding the geopolitical stakes behind EUV technology is crucial. It's not just about manufacturing efficiency, it's also about maintaining technological leadership in a global landscape.
If you found this deep dive valuable, hit the like button, drop a comment below on what tech mystery we should decode next, and subscribe to never miss an episode.